Well, good afternoon, everyone. Hope you are enjoying the conference today. My name is Arun. As I was introduced, I lead the strategy and product management for IBM Quantum Safe. This is a very interesting topic as we all hear in the context of quantum and quantum computing advancement. But I'll take a few minutes to get all of us on the same page. And then we will talk about how we can all collectively address this problem that we have today. I'm part of the quantum business unit, which has twofold mission. One of my colleagues always say that, you know the Spider-Man's quote, the great power comes with great responsibility. So while we bring the useful quantum computing to the world at the same time, we are equally responsible to make the world quantum safe. So as part of that, I would like to talk about what is this post-quantum cryptography, or what we call in IBM quantum safe cryptography. And will share with you my perspective, as the topic itself says, IBM perspective here. So we'll make sure that we all here are on the same page. What is the quantum safe cryptography? Why it is important? Who should be worried about this? And when this Q day is coming, people call this, and then how we can get embarked on this journey to quantum safe together. So quickly, getting to the why part, we all understand that currently cryptography and the modern digital world that we live in, I think it is so pervasive that every place we go in, every system that we touch, financial system, internet protocols, all the infrastructure, critical infrastructure, I think wherever we need security, privacy, compliance perspectives, I think it is very, very important that we understand the implications of cryptography in our environment. So you can say I don't have to belabor the point, but just wanted to make sure everyone understands. But the cryptography is today at risk. Why? Because we are all here in this conference. We understand the quantum computers are advancing. Based on the MIT professor Peter Shor, he suggests that the quantum algorithm that he has written, if we use that with right caliber of our quantum capabilities, the PQC problem in general, by looking at the current classical cryptography that's using prime factorization problem, would be solved by quantum computers within hours, not the millions of years that our classical computers take today. So the idea here is to understand that what are the implications. So any asymmetric cryptography, which we call about any data in transit security we have through internet, all of our credit card transactions, all of our mobile banking, all of our critical digital signatures that we have for our online document signing, and all of those things are at risk. So what can be these cyber criminals do when these quantum computers become what we call cryptographically relevant quantum computers? So one thing they can definitely do today, while we do not know if there is a quantum computer that is cryptographically relevant today, but what they can do is they can harvest the data today, and they can make sure that the data is stored until a CRQC is available in future. But once that's available, I told you what they can do is obviously fraudulent authentication, obviously the part that they can decrypt the data and find the crown jewels, but also the sensitivity that we have around forging the digital signatures. So any of the systems where we use these things in our day-to-day environment, those all will be at risk. So what is quantum safe cryptography? So we all understand that there are multiple point of views on quantum safe cryptography. What I would like to just make sure that everyone understands, the quantum safe cryptography is based on a new mathematical problem built for classical computers. And it is not something that you need quantum computers to build quantum cryptography or quantum computing or post-quantum cryptography. So this is a new mathematical problem based cryptography made for the classical computers. But this problem cannot be solved, this math problem that we have in PQC cannot be solved by today's classical computers as well as the future quantum computers. So that's the important part. Some of you have noticed that 3 weeks ago on August 13th, NIST has announced the PQC standards, post-quantum cryptography or quantum-safe cryptography standards. And you see all 4 finalists that were in the round, and 3 of them have been FIPS certified. And I'm proud to say that all of the 3 that we have here have IBM contribution in them, co-developed by IBM and other industry and academic partners. So these are the 3 algorithms already out as FIPS certified standards. So next question is, who should be worried about the post-quantum cryptography related issues that we talked about? One of the things that all the regulated industries, obviously they have data sensitivity or the privacy compliance requirements. So all of them regulated industries are impacting this problem with. So, and then second one is, who are the personas in those industries that should be worried about? So we look at all the CIOs who have the business applications ownership, CISOs who secure the network and the environment in their enterprises. And then also we look at the other chief risk officers, the chief data officers who have the ownership of securing the data as well. So all of those, predominantly the custodians of the data and security in the enterprises, should be thinking of the post-quantum cryptography as one of the initiatives. The question is often asked, when is this Q day coming? Do we know? Do we have some anticipation of that? So there are multiple, you can say, subject matter experts on this topic. They have been talking about that when this problem will be eventually be realized and when quantum computers would be of caliber that we would be able to crack our encryption technologies today. And I would say that range varies, but there are some subject matter experts like Professor Muska at the University of Waterloo and the NIST NCCOE. They have been doing research for several years and looking at the quantum computing advancements as well. And there is enough insight and knowledge is that sometime end of this decade is the time frame. Could that be faster? We have been seeing a lot of other MIT research papers to see how this factorization problem can be addressed faster along with the quantum computing algorithms, but other techniques along with that could be even advancing faster. So I'm not here to scare everyone, but these things we really do not know, but this is the timeline that many subject matter experts already say it could be somewhere by the end of this decade. So we also know that the reason knowing that this is somewhere at the end of the decade, in the US, the federal agencies have already been mandated with this. So the National Security Agency, if you see on the right side of this chart, that suggests that somewhere in 2030 or 2029, you see those yellow and red 2 bars. They are saying any vendor who's providing software or networking equipment to them, they must be post-quantum cryptography compliant or quantum safe compliant. So this is the timeline already being mandated by government here, which means the time is supposed to be starting now, so we have 4 or 5 years down the road to make sure that we are post-quantum cryptography compliant. Hopefully that answers you the question of when exactly, and not only in US, we are monitoring these trends across the globe as well. So every other country is looking at the NIST guidelines, preparing their own guidelines for post-quantum cryptography initiatives. And we have been helping in many of them and connecting with those government or the industry coalitions as well. So let me talk to you about the how part, which is more important because I wanted to lay off the land to everyone that who, what, when, and those things are common across all of them. But this is the how part where we have been helping across the globe hundreds of clients that we have talked to either in the enterprise space, telecommunications, financial services, government. All these organizations are already getting, you can say, understanding the problem first, and then also initiating a project within those enterprises that how they can embark on this journey to quantum safe. So one of the things that we all know that this is an ecosystem problem. It's not just IBM who is building the technology or other vendors building this technology and we will be all quantum safe soon. We understand that this requires a lot of other participants to ensure, because if you talk to any enterprise, they will say, I have software, hardware, services from 69 other vendors across the globe. How do I make sure that what I'm getting from them is quantum safe or not? So it is obviously an ecosystem problem. So how do we address this? So we say we are together in this journey. IBM has 6,700 plus software products. We are going through the same journey as many of our other enterprises are. Same thing we do also see that we have our CIO who has 3,000 plus applications. So we are going through that process just for the application side ourselves as well. So we see the enterprises who are in that class. We understand that how we can together help. And there are ways that we can rally these industries together. And that's one of the part that we are talking about, bringing the industry consortium. So for example, in the financial services, we have been participating and working with the North American ACH Payment, Emerging Payments Association in Asia, and then also some of the government bodies and those related consortiums like MITRE has one. We have a couple of friends here from MITRE as well. They are working with government agencies, but also making sure that we do have the open community, open standards community, open source community. So we have initiated Open Quantum Safe project, but also working with the NCCOE, the National Center for Cybersecurity Excellence. So we wanted to make sure that we bring the PQC migration as an initiative so that we share the knowledge with the industry, cross industries, and then initiatives that can help this migration successful. Because I come from the cybersecurity background and we know the SHA-1 to SHA-2 transition has taken people 5 to 7 years. We are talking about this problem which might take a little longer depending on the size of the organization you have. So we just need to make sure that we understand and leverage those consortiums, understand those industry guidelines and how we can work together on them. What IBM is doing in this, we bring the services and technologies together to help our clients on getting on this journey to quantum safe with what we call IBM Quantum Safe program, which is basically services and strategy that we can handhold our clients, enterprise clients, and help them understand what are the risks associated with this, how they can put a plan together to transition to post-quantum cryptography. And then also the technology that we can bring together, because we understand there are primarily the 3 key steps. And we have seen these steps across the other guidelines that you see from NCCOE, or the recent report came from White House on the PQC, where they have mentioned that there are $7.1 billion investment across the federal agencies for next 10 years for the PQC migration. There are few standard and key steps that everyone and every enterprise has to do. And those are discovering your cryptography, because that's one of the important steps that you have to know. Without knowing where your crown jewels are hidden, how would you prioritize them and how would you fix them? So that's very, very important task. We do have a technology called IBM Quantum Safe Explorer to help you find the cryptography discovery within your business applications. But also, you have to observe your business network, and you have to prioritize the cryptography inventory that you get from discovery through the network and applications both. And that's the part we talk about here in the quantum safe posture management capability that brings you the posture of your cryptography, but also enables you to prioritize the cryptography inventory so you know that where your crown jewels are, where you need to meet your business compliance requirements, where the risks are. And then based on those risks and vulnerabilities you identify through the system and inventory of cryptography, you prioritize which one you need to remediate first. And the last step is obviously what we call transform your cryptography, which means remediating, moving classical cryptography to post-quantum cryptography or quantum safe cryptography. And that's where we see the opportunity is what we call an IBM Quantum Safe Remediator, which is a tool and capability that can enable you to see the set of immediate patterns that you can apply. For example, you might say, I have a legacy application written 25 years back. How do I really secure that application? How do I don't know, the programmer is not there, it was written in long ages ago, and I don't know how to fix that. So there are patterns like you can put a proxy before that application, and it does the magic to the outside world that it's quantum safe, but behind the scene, you can still work through in the hybrid mode. That's the example. There are times when we heard from the COVID days, many clients who asked that, hey, majority of my data has started to go through the VPN tunnels, virtual private network tunnels for security purpose. So all the customers and partners accessing my data through VPN tunnels. Can I make the tunnels VPN secure or quantum safe? So those are some of the other patterns we see. So this is, the technology is evolving. We have started these technologies rolling out since last year. We have had several clients already using these, and we have a roadmap. Our roadmap is not just the technology when we want to bring, but our roadmap is directly relevant to the industry-triggered events. When governments across the globe are seeking and looking for those technologies, and when we can help them deliver that. So I think it's based on those timelines. And IBM is, as I mentioned, we are in this journey together. We are bringing our software, hardware, and those capabilities also to be quantum safe. And some of you might already know that IBM mainframe Z16 is the first mainframe platform that is quantum safe already since last year. So this is, I think, important part for us to really know. And we are embarking on this journey to make sure that the capabilities we bring our portfolio are driving towards the industry needs that we see. One of the questions that many of us often ask in this world, that how do we become or make our future quantum safe? And this word comes in often called crypto agility. And I just wanted to share the perspective that we are building and helping our enterprises also, is that this is an ability for any enterprise or any system or network or an application to really see that how you can be agile in the sense that when there's a change in your cryptography needs, because NIST is saying these are the new 3 algorithms, who might know 5 years down the road, they might say, oh, here are 3 more. How do you make sure that your transition path is built in such a way that you have capabilities underlying that can enable you to easily upgrade, easily retire, easily modify whenever things needed? And that requires you to have a foundation. And that foundation we talk about is built on this framework, which is based on the architecture, the automation, and the governance. And we need to make sure that those capabilities are built in such a way that when you try to replace an application or change an application, you do it one time in such a way that you don't have to repeat the same process again. So either you abstract some of the things or you automate some of the things. So those are the key ways to look at how do we become agile. And my last slide is, obviously, we all ask this question, that how do we become quantum safe, and what are the key steps for all of us to take on this journey to quantum safe? And we have, as I mentioned, we have looked at many other industry trends. We have looked at other clients' journeys. And this is a collective knowledge of over the last 18 to 24 months that we have been talking to enterprises. And these steps are quite common across all of them. There may be few steps not needed or needed, extra steps needed at some enterprises, but these are very typical in general. So first, as I mentioned again, you have to really know where your crown jewels are. So do the discovery, do the prioritization as a second step, and then start implementing the quantum safe cryptography in your enterprises. And then build the environment in such a way that it is crypto agile. So the things that I talked about, that how do you bring those things in place? And then making sure that the skills are other part, that not every organization can have the cryptographers or crypto engineers in the organization. So how do we use the automation? How do we use initially the type of capabilities that we need in terms of being agile? So this is, I think, skills are important as well, but also the technologies that you bring to your environments have to enable you to be agile as well. So hopefully, I think we have lots of content and information for you to read. and know about this. But thank you again for your time, and hope you liked the content and you understood where we are on this journey to quantum safe. Thank you.